Hi, and welcome to this A-level question on a reaction mechanism and percentage yield that's specifically about a chemical called chloral hydrate, which is used in medicine as a sedative. So it's of interest for people who might want to think about how some of the ideas in A-level chemistry are applied across to an area like medicine. So let's have a look at the question in its entirety first. It's an 8-marker, and what I'll do is I'll split it into part A and part B in a moment. So where it says nucleophilic addition reaction, technically that tells you what reaction mechanism they want you to use. So if you've done your recall work on nucleophilic addition, the first 5 marks should be quite straightforward to get. So let's have a look at the part A a bit more closely. So it says the reaction of trichloroethanol, which is on the left-hand side, with water is nucleophilic, and it's a nucleophilic addition in particular. So it can be catalyzed by small amounts of hydroxide ions, and asked you to complete the diagram and suggest a mechanism. So relevant dipoles, first of all, let's think about what they might be. So going back to our nucleophilic addition mechanism, obviously you're going to make use of the fact that the carbonyl bond there, C double bond O, is polar. But you've also got polar bonds inside that particular part of the molecule as well, the 3 chlorine carbon bonds. However, because they don't change, they're not relevant. So that's how you make the decision when they say relevant dipoles. So I've decided to put a lone pair on the oxygen on the OH. You could have also drawn an arrow straight from the negative charge. That's also okay. Either of those are acceptable. Then you break the pi bond in the C double bond O and you create an intermediate. So 2 electrons have gone into the oxygen atom. So we can pop those on there as a negative charge. And also I'm going to stick them on as a lone pair. So in textbooks, this mechanism is covered by either having an H plus at this point or a water molecule. So how do we decide between which of those two to use? The clue is in this part of the question where it says it's catalyzed by small amounts of hydroxide ions. If there was H plus in the mechanism, then that would suggest that hydroxide ions aren't present because, as you probably know, hydroxide ions and H plus react together to make water. So therefore, H plus is not the way to go in this particular case. We also need to be aware that because the OH minus is being regenerated at the end, because it says catalyzed, we need to have an OH minus at the end of the mechanism somehow. So if I put a water molecule on there, adding in the lone pairs and the dipoles, I can stick the curly arrows in. Now again, I could have drawn my curly arrow from the negative charge on the oxygen. I chose to draw it from the lone pair, but you can do it either way. The important thing is that the hydrogen-oxygen bond in water is broken. That's the bit that lots of people forget. And then, like I said a moment ago, we put an OH minus in at the end as well. So the hydroxide ion has been regenerated. So now let's deal with the percentage yield part. So it says the recommended adult dose of chloral hydrate as a sedative is 250 milligrams 3 times a day. They want the mass of trichloroethanol you need to make 1 week's supply of chloral hydrate, assuming a 60% yield. So we'll deal with each of those things in turn. There's a couple of things going on. Firstly, we need to work out the mass in grams of a week's supply of chloral hydrate. And it says that the dose each day is 250 milligrams. Now there's 1,000 milligrams in 1 gram. So let's take the milligrams first. Each day is 250 times 3, so a week is 7 times that, which makes 5,250. Dividing that by 1,000 to 200 grams gives you 5.25. So from the mechanism in the first part of the question, you can see that the number of moles of trichloroethanol to the number of moles of chloral hydrate is 1 to 1. So therefore, the number of moles of chloral hydrate in 5.25 grams, that's your week's supply, is 0.03. I'm just going to say 0.03. You can obviously see I've left the calculator value in there. So that's the number of moles of chloral hydrate you need for a week's supply. However, that's if you have 100% yield. Now, if you've got trichloroethanol with 100% yield, it's going to be the same amount that you need. So in other words, 0.0317 moles of trichloroethanol would technically, in theory, make 0.00317 moles of chloral hydrate. But the problem is it says it's a 60% yield. So to account for that, you've got to scale that up. And to do that, you multiply it by 100 over 60, and that gives you 0.05. Still keeping my calculator value. Now I convert that into mass. Now it gives us the MR of trichloroethanol in the question, so I just multiply it by 147.5. And I'm just going to pop it in at 7.80. Okay, hopefully this has been a useful look at a typical A-level style question applied to a medicinal molecule. Thanks for listening. Until next time, see you soon.